Hello everyone, Ankesh again. I hope you are finding this video series about ESP32 informative and beneficial for you. Continuing with our task of knowing more and more about ESP environment, today we are going to build a program from scratch. That means there is no template that we are going to use as we used in our previous examples, wherein we used an example template from Espresso. Now this time we are not going to use any template whatsoever. We are going to start writing an ESP program from scratch and from the command line. So let's begin. Open a terminal and probably you should navigate to the directory where you want to create the project. In our case, I have already created a directory for us which resides in my documents folder. So I'll go to demo projects for YouTube. I made a demo project for you before starting this video itself, but we'll create a new folder and we'll start everything from scratch. I simply copy the files from my previous project so that we don't waste time on getting the content for building the program. So before we can go ahead, again we have to source the Espressif toolchain first. Of course you can add this sourcing of toolchain in your bash.rc, but I prefer it like this. I do not set global variables. I define my variables as and when required while building the program, while executing any task. So again, for this case, I have to first source my toolchain here, and then we can begin with the ESP IDF. So I'll write source ESP underscore 5.5. Yeah, ESP and export.sh. Let me just silent this system sound. It is quite annoying. Okay. Alright, so I think idf.py is sourced here. Now for starting a project in Espressif, it is very simple and very straightforward. You just have to write idf.py create project. Oh, these sounds are still coming. idf.py create project and give the name to the project. So in our case it is for say YouTube demo is the name of my project. So I'll create my project here. So let's see what happens after we run this command in this directory. If we do ls-la, so in this a folder is created with the name YouTube underscore demo. This is our project folder. Let's go inside our project folder. So here you see I have one cmake lists.txt and there is one main. Let's go inside main. Inside main we have the main file, I mean the YouTube underscore demo.c. This is the main.c which is going to run when we build this program. And then there is cmake lists.txt. Let's just have a quick go through, a quick view of the contents of this file cmake lists.txt. So I'll write sudo nano cmake lists.txt text, and it says that IDF component register inside brackets there is written srcs, and in quotes there is our file, the main file, youtube underscore demo.c. Next it says include underscore dirs, include directories, and in quotes it says dot. What does this mean? So srcs basically stands for the source files. So in this case right now we have only one source file, that is youtube underscore demo.c, and we don't have any other file which we need to include in this program because we haven't made any header files yet. So this include directory dot specifies our current location, that is we are inside the main folder. So this is where this dot points to. So this tells the build system that these are the locations and files which you need to look for when compiling the program. So this is a very important part of making a project from scratch, so keep in your mind before we move forward. So let's move ahead. I think you've already seen it's pretty simple. This is not anything complex to discuss more about. So it's there now. The thing is that usually our program does not reside in one single file. We have many parts to our program, which include some certain codes, which these function calls inside these files are called as per the requirement of the program. So what do we call? We call them components in case of ESP IDE. It is also called components in case of other build systems as well. Here also we call it components, and there is a process to create component in Espressif. So for creating a component, first what you have to do is you have to create a components folder, and this components folder you can keep it inside your main directory as well, but it is advisable that you keep it right above your main directory inside your project folder. So our project folder here is youtube underscore demo, and we'll create a components directory inside our youtube underscore demo folder. So we'll go one level up, or I can simply write mkdir make directory and provide one level up key, and then I have to write the name, that is components. So this is my components folder. It is already created. Let's go back and see if it is there. Yes, the components folder is here. Now go inside this components folder. There's nothing inside it right now. Now the command that you are supposed to run to create a component is called idf.py. Create component. And you have to provide the name of component which you want to create. So in my case I want to create two components, that will be uart underscore rx and uart underscore tx. For this I have already prepared my demo files so that we don't waste time on writing the code. I'll probably provide a link to this code so that you can use it as a template for your future projects which you want to do. But for now, for the sake of this video, I'll simply copy those files here so that we can quickly move ahead with the procedure in case of this video. So I'll write uart underscore rx and I'll create one more component, uart underscore tx. Alright, let's see what happens. Let's do an ls and see what files get created. So you see two folders are created. Let's go inside one of the folders. We'll go inside tx, cd uart underscore tx. Here again you see a source file is created, the name of which is uart underscore tx.c, and a cmake lists.txt is created. Let's have a look. So I'll open sudo nano cmake lists.txt, and exactly same format which we saw in case of main. There's no difference. So in this way you can see every source file along with its header file is is assumed as a component in the CMake build system of Espressif. You need to understand this. Even main is a component, and other source files which we include in this project is also a component. But there is a directory based hierarchy structure. So we can place components inside the main also, but as per the Espressif system and the way build system is designed, it is advisable that you keep components and main at the same level of the hierarchy inside your directory structure. So that is what I have done, and let's proceed after this. Now what I'll do, I'll copy the files, I mean the source files. As of now there's nothing inside urtx.c, just a template. I'll copy the code from the previous build project, and I'll share the link for that project with you in this YouTube video, from which you can see there's nothing inside this file. I'll simply go back and create a copy of the files here. Sudo cp is uart with component inside components. I'll go uart underscore tx. Copy this here, -r. So I have copied everything here. So you can see the files sudo tx.c. So I've already put a program inside it. Similarly, I'll do for the rx as well. So I have copied both the components, uart_rx and uart_tx here. Let's first check if the components of the rx got properly copied. I think they are already here. So underscore rx.c. Yes, it is there. Now similarly, I'll go to my main, and I'll copy the main file as well. So let's go inside the main folder. As of now, the file name here is youtube_demo.c. The project from which I am copying these files is uart with component.c, so I'll have to change the name accordingly here. So simply I'll do sudo cp, back to the previous project folder, which is uart, and inside this main, and I'll copy only the uart with components.c file here to my main directory. And what I'll do, I'll rename this file as youtube_demo.c. So sudo mb uart component.c as youtube_demo.c -v. Yes. Now we have one file with the components of uart, and let's verify it for sudo nano youtube_demo.c. Yes, the program is there. Now the most important part. Now we have to create entries for the files. Now we have to create the entries for the files which we need to access in our program. Now our primary CMake lists.txt doesn't contain entry for the component that we have created. So we have to create the entries for the for those files which we want to basically run. So I'll go back and I'll for reference, let's check out the cmakeLists.txt of the previous project that I built before this. It will be better for explanation, otherwise I'll have to speak more words for making you understand. So here we have a cmakeLists.txt. I'll open this file. So this is our parent cmakeLists.txt. We don't have to touch this. This was created when we ran idf idf.py create project. Similarly, in our project also, the one which we are doing right now, you will see same file is created in the YouTube demo as well. See, exactly same with only the project name changes, that is YouTube_demo. Now the entries that we are supposed to make is inside the main folder, because our app_main resides inside our main folder. So all the source files which are required inside the main needs to be executed, or to be told the builder that please compile these source files before you run the app main. So let's go inside our main folder first. We have cmakeLists.txt here, and I'll do list.txt. Now here I have to provide the entries for the files which I am going to which I basically need compiled for this project to run properly. And to make it happen, what you have to do, simply in front of srcs add the path and the name of those files in this fashion, the way I am doing it. So from this location, from inside main, the location of those source files is one step back, components. In components there is a folder called uart_tx, and inside uart_tx we have a file, source file called uart_tx.c. Similarly, we have for the rx as well. So I'll write this components /uart_rx. So uart_rx.c. Okay. Now, as of now, it is only including the directory. It is only including the current directory. We have to provide path for the other includes as well, which resides in our component sections, because in component we have include folders for the uart_tx.c and uart_rx.c. So we have to provide path for that as well. So here again, inside the codes, you have to provide the path, components uart_tx /include. So this is one path. Next path, components /uart_rx /include. So we have provided the include paths for our header files which reside inside our component section, and we have provided all the source files which are needed to be built for this program to run successfully. So let's save this, control and do Control X, close it. Now I'll go one level up and I'll type idf.py set target. In my case the chip name is ESP32 and I'll run this. So you see now the build folder is created and one SDK config is also created. Now simply I have to write idf.py. I can provide target here as well, but this is not necessary, this is not mandatory. I can simply write -didf underscore target equal to ESP32 and build. So you can see now it is building the project. I'll pause the video to save time on the building process, and I'll restart the video once it reaches the end of the linking. For this project I am using a very old laptop. This is not a very fast machine. You can also use your Raspberry Pi to build the expressive programs in the very same way which I am showing you right now. Raspberry Pi is it's a ARM based ARC. It has a ARC64 architecture, and as of now the operating system doesn't work very fast, and making programs on command line is fairly easy and simple on the Raspberry Pi as well. So this process is completely same in Raspberry Pi. You can simply make and build expressive programs using your Raspberry Pi also. Probably I'll make a video using building the same program using Raspberry Pi after this. So I have already connected ESP32 to the USB of my laptop. Once the program is built, we'll provide permission to the port so that we are able to flash the program onto the chip. Okay, so I'll write idf.py. Oh, first let's provide the permission. So I'll write sudo chmod uo plus rwx slash dev slash tty usb 0 -b. Now that the permission is given to the port, we can go ahead and flash this program onto the ESP32 chip. For that, we have to write idf.py -p slash dev slash tty usb 0, that is our port, and write flash and monitor. Okay, the chip is not flashing for some reason. Why is that so? No serial data, unable to verify flash chip connection. Okay, I think some part of the cable is loose or what's it. Let's run it again. Yeah, I think the cable was little loose. So yes, the program is working fine. I am sending 1 byte of data and receiving the 1 byte in the RX pin of the same ESP32. Both the components UART_TX and UART_RX are working very fine. Now there is a catch to it which I did not cover previously because I wanted the flow of the build system to be smooth. Now there is another section to this build system. Right now I only spoke about the components which you created yourself or which I created myself, the files which I wrote, the header files which I created. But for running the program properly, we need the pre-built drivers which come bundled in the ESP toolchain. Now when we build the program, it is necessary for us to provide the CMake build system with the relevant information about the list of drivers that we require for our application to run properly. Now where do we do this? We do this where we write our code that access those peripheral drivers. In our case, we are accessing UART TX and UART RX. We created 2 components. Now this UART TX and UART RX both require the UART driver and the GPIO driver to function properly. So for compiling this UART code, that means UART_RX and UART_TX properly, we have to provide some entries inside the CMake lists.txt file which resides inside those component directory. Let's go there and find out. So I'll do cd components. Inside components, first I'll go inside UART_TX. Open the source file first. So in the source file, you can see that first I am basically initializing the struct that basically provides the necessary information, the init information for the UART driver to function properly. That is its baud rate, the transmission width, which is 8 bits in this case, parity bit, and other information like stop bits. Now for making this driver run, I have to include this file called uart.h, which resides inside the ESP-IDF toolchain, gpio.h and log.h. Log.h is used to display information in the monitor screen. I am using this ESP log I. ESP log I means ESP log information. Similarly, there is ESP log E and ESP log W. There are different log levels which are there in ESP, for which we'll have another video where I can discuss in detail about the ESP log levels. So here I am providing an information whether about a task, about a function that I executed, and whether it is executed properly or not. I print the relevant information in my monitor screen. Uh, so writing these include files right here won't let the build system know the exact location of the header file ur.h and gpio.h. And also we need to understand that the source files related to these header files ur.h and gpio.h are also supposed to be compiled and converted into an object file before this program can build successfully. So those source files are needed to be added in the build system. Now there is a different procedure to add those components which are already provided by ESP IDF into our own application. Now for doing this, we have to go inside the cmakelist.txt file of our component. The modifications which we made earlier was in the cmakelist.txt of our main folder. Now this modification we need to make inside the cmakelist.txt file of our component section. Let's go and do it. So I'll do an ls, and you see that there is a cmakelist.txt created when we ran the command idf.py create component. Now I'll open this file because we already copied this file from the my previous build, so it will contain all the necessary entries which are supposed to be made. So here everything else is same, only one more statement is added, which is priv_requires. So priv means private and requires means these are the drivers or the header files or the pre-built API sections provided by ESP IDF build system which are supposed to be added in our build. Now there are two options, one is requires and one is priv requires. Here I am using priv requires, that means privately requires. Privately requires means the scope of this inclusion is limited to this component only. Okay, so we are currently inside the directory ur_tx. So when I build this system, the scope of this inclusion is limited to the ur_tx component only. That is what priv_requires means. As of now, there are no other source files which are present, or there is no other subdirectory below ur_tx which is needed to be compiled. So as of now it is not so relevant in our case, but I just wanted to share it during this session. So there are two types of entries which we can make while including the pre-built drivers from the ESP IDF toolchain. One is called requires and one is called priv requires, depending on the use case and scenario. Similarly, I did it for the ur_rx as well. I'll go inside the directory and show you. So here also privately requires same, because I'm accessing UART again for the RX section as well. So these are the two drivers which I needed to be included in my build. So I provided the priv_requires ESP driver_UART and ESP_driver_GPIO for my build to be successful and complete in its manners. So the result we have already seen. Our program is running properly without any errors. You can simply run the monitor again. idf.py p/dev/tty usp 0 monitor. So yes, it is running properly, sending 1 byte, receiving 1 byte, sending 1 byte, receiving 1 byte. So to conclude this session, what I find is that the build system provided by the Espressif is pretty simple and straightforward. It's very methodical and organized too. We can very easily create a project from scratch and make it work in no time. And this system is not only available in our laptops, we can also use a Raspberry Pi to build Espressif programs. So I hope this information is useful for you and proves to be beneficial in your future